Dogs Eye here once again, and today's video is going to be about a solution to a problem that I had with the empty solar mounts. In high winds, they would wiggle here, and on the house array and also the shop array, I've had the same problem. When it gets really high wind, I'm always worried about the adjuster breaking. On the mounts that I bought that had been in through a tornado, that was the failure point, was the adjuster on the empty solar mount. And so I've been thinking about a solution here since I put my first array up over 2 years ago. And I finally run across some pipe fittings I thought that would work for my application. And so I decided to use those, and I'll show you here now in the video how I put that all together and how it all works. So thanks for watching. Let's get started. So on this tilting array, what you got here is that big pipe is where your pivot point is to tilt your array. And then right behind it, they have this smaller pipe here, and that's where your adjuster hooks to. And then they got a long pipe on there where you can crank it. The problem you run into is with the adjuster that close to the pivot point is it creates a lot of play in there. And of course, even have a light wind, you'll walk out here and you can hear that squeaking, as it keeps wiggling on that big pipe. But in a real high wind, you'll see the ends of the array really rocking back and forth. And I've wanted to eliminate that for some time. It's taken me 2 years to come up with an idea. But I'm going to show you here how I made a brace for it and install it. So let's get started. So I bought these structural pipe fittings from Zorro. They're made in India. They're fairly cheap. I don't know if they were $12 to $15 a piece, something like that. They fit a Schedule 40 or Schedule 82-inch pipe with an OD of about 2 3/8. It's pretty sloppy in here, and we're going to address that too. They got a set screw in the side, and that's going to stay, and I'll explain why later. This cold riveted pin here is 3/8, and I've been removing those and installing, boring it out and installing a 1/2-inch grade 5 bolt. This part here will bolt up to my empty solar mount frame, and then of course I'm going to have a Schedule 40 pipe that comes out of there, and then I'll show you the rest of the mechanism I'm making here for the brace. So I got my pin removed. I grind the head off and pound that out, and I've been boring these out to 1/2 inch. Okay, then I go slide it on a piece of pipe, add a small piece of sheet metal shim here opposite the set screw, then I'll tighten the set screw. Then I'll drill my hole in here. Then once that's drilled all the way through, then I'll remove that sheet metal shim, stick my bolt in here, and then I'll be able to tighten down this set screw. And what that does is it wedges in your bolt in here so there isn't any play in this part here. Okay, we want to eliminate any play that might possibly be in between the pipe and the fitting, because the fittings actually are quite a bit larger than the pipe, so we want to eliminate any play so nothing wiggles on there. Okay, I got my set screws tightened up. I'll take it out first, and I put a little blue Loctite on it, and then I screw it down in there. My bolt here is long enough so that the shoulder of the bolt, there aren't any threads here where it's inside there. Of course, that's to eliminate any play. I've been throwing a washer on each side, and because the bolt is slightly longer, and I want to make sure I got enough threads there, but your shank fits in there, and then tighten that up. Same thing here on this part. My bolt, the shoulder is long enough here that it sticks through here. Then I'm just putting a washer on one side with another lock nut. In between here, I'm putting a 7/16 washer. They're a little bit thinner than a 1/2 inch washer. And that way it takes up any space in there. Some of these pieces here were ground, I noticed, and some aren't. But I've been taking the ones that aren't ground and touching up slightly if they're not thin enough to get my washer in there, just to clean them up a little bit. And then just repainting them with some cheap paint. But yeah, that finishes up this end once you get this tightened up. And I make it so that it's just slightly snug here, but it, you can still turn it. So you can do that because you got your washer here, and that gives you just enough bite on your thread there. But your shank still goes all the way through there. Like I said, we're trying to eliminate any play in here because we're not going to be all the way to the end. So, anything that's on the end of that array is going to wiggle more than it will at this point. Okay, moving on to the next step. So I got these all together. As far as the pipe, it's 2-inch galvanized Schedule 40. It'll come in a 21-foot long stick. And I actually planned on them being closer to 10 foot each, but I got doing some measuring with the array tilted down to 60 degrees and back up at about 17, and ended up figuring out it was going to be about 7 foot. So it was actually a little less than 7 foot, but I decided I'd just make them all 7 foot long. And so I got 3 pieces out of each stick. I actually had ordered 3 sticks, but I guess I'm going to have an extra. Now, the reason there's 6 of them, 2 are going on the one array that has 8-inch poles, and 2 are going on the array with the 6-inch poles. And I have 1 more array that's going up probably yet this year, and that's going to be 8-inch poles. So that's why you see 6 of them. So while I'm at it, I'm making all my pieces so I have it all ready to go when I'm done. What I got here is some Schedule 82-inch. It's left over from when I made my adjuster pipe on my last array, if you saw that video. And what we got here is a crossover pipe fitting for 2-inch pipe. We're going to run a pin through there, and then my other galvanized pipe will go through here. This part here is going to get welded to the pole. Going to put a 3/8 bolt probably here for stop so they can't slide off the end. I don't know what distance it is, but I am putting a gusset here to the pole. And for those of you who've seen my other previous videos, you've seen this thing before. It's the 8.5-inch diameter rotor hat that I cut off and used to make my top plates and bend my rods. So basically what I've been doing is just clamping in here, following along with the torch and cutting that radius out of there. Do it closely, then I got it marked here, and then I'll take this other piece and that'll make my bottom gusset. So I'm not planning on putting a gusset on the top, simply due to my pin there, and I don't know for sure what length I'm going to have. But anyway, I'll get these all done and start getting stuff welded up, and we'll get moving on. I got the first one welded up. I ended up making it 11 inches long from here to here, and basically I'm going to use a bolt here with a nut here that's drilled out, and a nut here, just a 3/8 bolt. That's to keep it so the crossover can't ever slip off here. I allowed for a little bit of room here for it to move side to side, because your pole ain't going to sit up there perfectly square to your piece. Basically, I just got my gussets, traced them out, and cut them, and I got my other gusset on the bottom. So I'll get the rest of these done, and we'll get them mounted on the poles. So I got my pipe here welded on with my gussets. The way I got them parallel to the center line of the poles is I just ran a string from the outside of the pole here over to the other pole, and that of course gave me a line parallel to my center line between my 2 poles, and then I was able to measure from the string to my pipe and get it all straight. Got these all welded on, painted last weekend, and today I'm installing the braces. So on this end here, I got it assembled here. You get your crossover on here. I still got to drill my holes through here. I'm going to come up with a different idea for that. I'll get to that later. But I just took a 3/8 bolt here, and I went through and I took a 3/8 nut, drilled the center out, and put it on each side. And that way I know for sure that it can't ever slip off there. On the other end, I just drill up here into the big frame here, the I-beam of the empty solar mount. And what I did here is I measured from the pole here over to the center of this in between here, and then I transferred that over, measured over to my beam over here. Then I just come back and measured from my beam and got my dimension there, so that way I'm centered here on my pipe. I have been adding a shim on the other end there. You can see it right there, and that's to correct the angle that happens when you tighten the set screw down. It'll vary a little bit just depending on the fitting, but that one's all bolted up there. Just drill holes in the frame and bolt it up there, and I'm going to go do the next one. So this is what it looks like when it's all the way up there. I got to set my angle here of my array using a protractor, and then I can drill my hole right there for my pin. And this way it'll always be at that summer angle for that hole, and I'll know which degree it is, which will work out really well. So I'm using a set angle here as a digital protractor. I don't even know where I got it, maybe Amazon or somewhere, but these are nice to have. I've used the set angle when it's lower, but when it gets up there at summer angle, I've been always having to climb up on a ladder, trying to measure it. So I just got done setting the angle on both sides of the array at each pole, and I'm ready to drill my holes in my pipe here. So I got that one drilled. Use a 5/8 hitch pin with your set screw size. You're going to end up using a drilling out the 5/8 hole. Half-inch would have too much play. I got the hitch pin at the local hardware store. It's just 5/8. When I got that in there, then I run my adjuster so that it pushes the front of the array down and makes my pin in there nice and tight. You can't wiggle it. So it keeps raining here, so I'm going to go work on this thing right there, and I'll show you what I'm going to do there. Sometimes, you think you have this great idea and all that, but I got looking at this a little closer, and I've got 1.25 inches from about the center here to that pipe. I was thinking about putting a T-handle on it eventually, but really ain't got enough leverage, and I think what I'm going to do is just buy some 8-inch or 8mm Allen wrenches and just dedicate them here to the array. Wouldn't do you any good if you flip the fitting around. It's still going to be 1.25 inches, to your pipe. So limit your swing. The advantage here is, if you want to use a ratchet and a bit, you could. I could buy a bunch of 8mm bits and then just have them here and buy a cheap ratchet or cheap breaker bar and hang it on each array and have it. So for now, that's all the modifications I'm going to do. Basically, I'm done here and show you what it all looks like from a distance. So you can see what it looks like here. The reason that the braces are this far up on the pole is because if you put your brace all the way down here on the bottom, what happens is when you tilt your array to 60, 65 degrees, your brace will be basically almost vertical and provide basically no bracing whatsoever. So I decided, I tried it this way, tried it that way, and in the end I figured I would put it here, and when it's at 60 degrees, it basically just sticks straight out at almost 90 degrees, and I think that'll work out really well. I did grab a hold of the end of the array and pull on it, and we got no play in the adjusters anymore. And basically, if you get your weight all on it, and the pole will wiggle a little bit, and I'm sure it will in high wind, but I'm not worried about that pole breaking off. I think this will work out really well. So we got these all drilled here for the different seasons, around the solstices and the equinox. So the very top one here is at 62 degrees. The middle one is at 40, and the bottom one's at 15. And then I just measured halfway in between each hole and drilled the other hole in case I want to move it halfway between the solstice and the equinox. So and then we're all done, and I got the other array all done, so these are all finished. So one thing I forgot to mention, it's a little tip here. If you put a little shim in there, along that pipe there on the top fitting, if you vary the length of the shim, it'll change the angle of the pipe when you tighten down your set screws. So that way you can get it to run straight. That seems to be a non-issue. So just a little tip there. I forgot to add it there when I was showing it, but that'll help you out a lot. So as you can see, it was a pretty easy and simple solution. It took me a while to come up with an idea, but I happened to run across another video. I think it was a Cornish rocker video they used for a solar array, and it had the crossover piece in there. And right away when I seen it, I know exactly that's what I needed. I knew I needed a pivot on both points on each end, but I also needed a way to adjust the length. Another big problem, if you were to put the brace down to the bottom of the pole, was the excess pipe is just slide it back, has to go somewhere. So, I had taken a piece of wood, and a long piece of wood, and marked it off and decided, yep, this is the length I need, and this is going to be the height I need. So this is going to work out really well. I'm really satisfied with how it turned out. On the next array that I'm going to build there, using MT solar mounts, that's going to be an interesting video. I haven't decided yet what I'm going to use for an adjuster, but I will be using the braces. But before that, I have another 4,000 watts I got to do on another array here I'm going to do, and that'll be in an upcoming video. If you like what you see here, hit the like and subscribe button. We got more content coming, and catch some rays, and we'll see you later.